So now we are going to do the deletion operation in the existing linked list. So as of now, the node will be present like that. Each node is connected together and the address of the successor will be placed in the node of the next field. So now we are going to do the deletion operation. First of all, we need to check that whether the deletion operation is performed in the list or not. So for that we need to begin with the L. So this is called as the L and another name we are going to make it as P. So first of all we need to check whether the list is present or not. If the list is present, we can do the deletion operation. If suppose the list is not present, we can't do the deletion operation. So if P is equal to null, we can declare that there is no list in the memory space. So we can't do deletion operation in the list. So we can say that the list is empty. Suppose the list is already there, we can do the deletion operation. So now we are going to perform the deletion operation in the existing linked list. So now we are going to write the else part. Suppose the list is there, we can do perform the deletion operation in the existing linked list. For that we need to have one statement to delete that value. So for example, in which value you want to delete. So if you are going to delete any data, the data will be choose from the user. So here I am going to choose the node is called as a 10. And now we are going to do the deletion operation of the first node. Else I am going to read the data first. Scanf %d ampersand x. X is called as the data in which we are going to do the deletion operation in the existing linked list. And now once we read the data, so x means whichever the node we want to delete, the data will be read through the help of the x. And we have to check that if x is equal to p of data. If the p of data is matched with the first position, for example, if I am going to give the x value is called as 10, so which means that the 10 will be placed in the position of first node. Now we are going to do the deletion operation because temp is equal to p. Now we are going to assign another name of the particular node is called as a temp. We can't do deleting the node immediately. Instead of that, we are going to make this node is called as temp. And now once we assign like that, whoever present at the next node, see the next node is called as a 2000, and this 2000 should be changed as L is equal to P of next. So whoever present at the next node, which means that this is called as the next node, and this next node should be called as L. So whenever we are going to delete the first node, you have to move the L position to the successor, then only we can do the deletion operation. So because of this line, the new next node will be become the L. Once we moved like that, then we have the statement to free the memory space, free temp. So which means that the temp will be now free to delete. So this particular memory space of the first node, whichever having the value, will be detached from the memory space, and this address will be removed, as well as the node also removed from the memory space. So now the 10 will be removed and the first node is become L, and value is called as 20 and address is called as 2000. And this is a way we need to do the deletion operation of the first node. Now I am going to delete the node in between of the existing linked list. So now the node will be deleting through the help of the else part. In this else part, we are going to write else p of next is not equal to null, which means that the next field should not be null, and the p of next data, which means that the p of successor data should not be null x, which means that whatever the data we are going to search, and if the data is equal to x, we should not move the pointer position to the next field, or else we can move the pointer position to the next field. Now we are going to check one by one. So according to this situation, we are going to check that the first node 10. So p of next not equal to null. Yes, of course, here we have the value address is called as 2000, and p of next of data not equal to x. For example, if I am going to delete the value is called as a 40, so x is called as a 40. So now we are going to check that the first condition p of next not equal to null is true, and p of next of data is called as a 20. So this condition is also true. So now the p will be moved to the next position, and now we are going to check this node P of next not equal to null. Yes, of course, here we have the address is called as 3000, and P of next of data not equal to X. Yes, why? Because the next data is called as 30, because P of next is called as 3000 and the 3000 having the data value is called as 30. So conditions become true. If it is true, the P will be moved to the next position. And now we are going to check that P of next not equal to null. Yes, of course, here the address is called as 4000, and P of next of data not equal to X. The P of next of data is called as 40. So it is equal to 40. So it is equal to 40 now. So the P should not be moved further. So the condition will be coming out of the loop. And now we have the statement. The statement is called as P equal to P of next. P of next is equal to, this is called as a P, this is called as the position. So P of next is called as 4000. P of next equal to this place, we need to address of this node. Okay, so how can you do the assignment? P of next is called as 4000 is equal to, now we are going to do the assignment, P of next, which means that P of next is called as 4000 and the 4000 next field is called as 5000, and this 5000 address will be placed in the position of P of next. Once we have the statement like that, next we can able to free this temp. So now this is called as the temp node is called as 40, because we already assigned that temp. So now we are going to do the statement free temp. So this statement is used to remove the memory space from the existing linked list. So once we remove from the existing linked list, the node will be detached from the linked list. So now the node is removed from the existing linked list, and now we need to change the address also, and this 4000 will be removed, and this instead of that we are going to have the address of 5000. So now 5000 will be connected and new logical link will be created between those two nodes, and this is a way we need to delete the node at the middle position.